So in 1.5, we talked about all the different things that you could do with functions. You can add them, you can subtract them, you can multiply them, you could divide them. You can create a composite function, which puts one into the other, okay? We also talked about domain in this section, so it's not on this. I'm not going to go too heavy on it just because I felt like I lost it like that last day. We'll review it again before your test. But this one just wanted you to, first one, add f and g. So I just go ahead and grab the 3x minus 1 and then add it to the x squared minus 4. And then the only thing you need to do is combine like terms and put it in decreasing degree order. So I get x squared plus 3x minus 5. Questions on that one? Okay, second one is subtracting. So this time we've got to change the signs on the second one, which is the g. So this would be like 3x minus 1 minus x squared minus 4. And then that minus gets distributed to both. So I get 3x minus 1 minus x squared plus 4, which is the most common mistake made, is not changing the sign on that 4. And then decreasing degree order would be negative x squared plus 3x plus 3. So you can only do that if it's an equation and you can balance it on the other side. Like if it was equal to 0, totally fine. But because it's not, you can't balance an expression. You could take a negative 1 out and put it on the front, but it doesn't go away. So you might as well just keep it the way it is. All right, then 3 says find f of f of g of negative 1. So remember the order here goes right to left. I'm going to take the negative 1 and plug it into the g first. So into this function, I'm going to plug in negative 1 squared minus 4 is 1 minus 4, which is negative 3. And then I'm finding f of negative 3. So I take my f and I plug negative 3 in there. 3 times negative 3 minus 1, which is negative 9 minus 1, or negative 10. And then remember, it's not a two-part answer. That last answer is your answer. So negative 10 would be the answer there. Questions on that one? Okay, and then 4, now I'm finding g of f of negative 2. I go right to left, so I'm going to find the f of 2, or negative 2. F of negative 2 first. Take the f, plug in the negative 2. Negative 6 minus 1, which is negative 7. And then I'm finding g of negative 7. So negative 7 squared minus 4, or 49 minus 4, which is 45. Questions overall? All right, so again, we reviewed, I also added in there like the domain of the composite functions when we talked about it initially. We'll go back to that on review. We're going to talk a little bit about domain today, but it will come back on your test review. All right, so open up the R.1 to 1.5 review. So this is just classwork turned to homework assignment because we're going to start it in class and then it'll be due tomorrow morning. I know it's long, it's like 28 problems. I know it's long. When I was creating it, I was trying to literally condense all of those sections into one, okay, which is why I'm going to give you time to work on it today, but you're also going to get to take it home and work on it until tomorrow. I just didn't want to skip over material and not review it. All right, so in the beginning, and I tried to label what they are, but some of these get grouped together. So like R.1 and R.2, there's a little bit of an overlap. In the beginning, we just talked about the two formulas that were in R.1, which was distance and midpoint. So if you want to make sure you review those. The distance, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. And then midpoint, which is x1 plus x2 over 2, y1 plus y2 over 2. Number 1 says, find the lengths of the sides of the triangle formed by the given vertices, then classify the triangle as right, isosceles, equilateral, and none of these. So you're going to use the distance formula 3 times. God bless you. Find the lengths of each of those sides and then classify it. So if it's equilateral, all 3 are the same. If it's isosceles, 2 are the same. If it's right, then a squared plus b squared equals c squared. Remember that when you're giving the answer to the lengths of the sides, they need to be simplified square roots. Actually, I have your quiz to get back to today. But when you're comparing them, they don't have to be. If you get square root 20 and square root 20, that classifies it as isosceles. But if you're providing the answers to me as a side, it would be 2 root 5 and 2 root 5. Questions on how to do it. So I'm going to give you time at the end to go back and how to do this, but I just want to kind of go through the material first. Okay. For number 2, it says find the equation of a circle with the endpoints at the diameter. So we need, of course, the equation of a circle here, which is x minus h squared plus y minus k squared equals the radius squared. And in this, hk is your center, and r is your radius. So if I give you the endpoints of the diameter and I'm looking for the equation of the circle, what's the first thing you got to do? Midpoint. Good. Find the midpoint. That's your center. Okay, so that's when you'll use the midpoint formula. And then you had options, if you remember how to figure out the rest of it. What's one way I could find the radius? Good. Find the distance between the two endpoints and then divide it by 2. What's another way? Sorry? Plug in one of those points with the center and find r. And then there's a third way. What other distance could you find that would help you out? What's the radius? The distance from what to what? From the center to an endpoint. Okay, so you could also use those two, and then you don't have to divide by 2. That's the only difference. Everybody would be okay to solve that one. Yeah, any questions? All right, number 3, find the intercepts, the symmetry, and graph the given equation. So intercepts, let's talk about that first. How do I find the x-intercepts? Good, plug 0 in for y. How do I find the y-intercepts? Plug 0 in for x. How do I find symmetry? So how do I test for symmetry to the x-axis? Not for x. Remember, it's always the opposite, right? So replace y with negative y. For y-axis, replace x with negative x. And the last one is origin. So for x-axis, we're replacing y with negative y. For y-axis, you're replacing x with negative x. And for the origin, you're replacing x with negative x and y with negative y. And then what? What are we looking for once we replace them? How would I know it's symmetric? If it goes back to the original, right, would match the original equation, or? If they're all negative. If every single sign is opposite that it was in the beginning, okay? So for every term, the sign would change. If it was positive at the beginning, it would become negative. If it was negative at the beginning, it would become positive. Yep. All right, and then graph, obviously, you can use your intercepts, you can use your symmetry to graph it. If that's still not enough information, then what could you do? If you had no idea what that shape looked like. Plug in points, okay? So when in doubt, plug in some points. All right, 1-1 was lines in the plane. So this is your slope-intercept form, right? Like y equals mx plus b. For the first 3 there, 4, 5, and 6, you're just finding the slope and the y-intercept. If there's no y-intercept, just state so. And then for 7, it says find the equation of the line that passes through a point that is A, parallel, and B, perpendicular to a second line. So for this, I need point slope, which is y minus y1 equals m times x minus x1. And I also need to know the relationship between the slopes of two parallel lines, which is what? Same slope. How about the relationship between two perpendicular lines? Good. Opposite reciprocal. So from the equation that they gave you, which is this one, you're simply just taking out the slope. So remember, you can solve that for y, put it in a slope-intercept format, and then get it from there. Or the shortcut's negative a over b is the slope. Once you have the slope from that equation, you're done with that equation. You don't want anything else. You don't want to use it again. So some of you used the b from that equation to plug in with for the parallel and perpendicular. Once you get the slope out of that one, you're done. You would then take that and the point to find the parallel. You would negate it and flip it and take the point and find that perpendicular one from there. All right, then we got into 1-2 and 1-3. I kind of grouped together because these were all about functions. 1-2 was identifying functions from points and from equations, and then 1-3 was identifying them using a graph. So there's 3 total ways to verify if something is a function. What am I looking for from points? What can't happen with a function? Good. X cannot repeat with a different y. So from points, all right, then we had from an equation. So when you're looking at an equation, what can't happen for it to be a function?
You can have 2 y's for 1 x.
Okay, so what does that look like in an equation format?
Y squared.
Y can't be squared or raised to an even power, or?
In absolute value.
Very good. Okay, and then the last thing, which is probably the easiest, from the graph, how can I figure out if it's a function? Vertical line. So you're looking for the vertical line test for 11 and 12. Hopefully those are easy. Those are simple yes or no. Questions on that so far? Okay, then we got to piecewise functions. And again, this was spread out over the 2 sections, but I just put it together in one. The first section, we just learned how to evaluate a piecewise function, like 14 and 15, where you've got to figure out from the function which one you would use. Because -1 is less than or equal to -1, I would use the top equation, and then I would plug it in there. And then in 1-3 was when we actually started graphing these. So remember, I gave you 2 options. You can either graph and erase part of it, or you can plot your points. So if I was doing that for the top one, I would plot from -1 and then less than -1. And then from the bottom one, which we now know is what shape? Parabola, shifted way. How? Down 1, okay? But I would plug in the points because I don't know exactly where that is. All I know about that is the vertex, right? So I plug in starting at -1 and then work my way to the right because it's greater than. And then 16 was difference quotient. Who could tell me the difference quotient? Yeah, that's what I thought, right? It's been like 7 to 8, 9 days. Okay, so f of x plus h minus f of x over h. This is how I figure out who actually did work over this break or who didn't, right? Because a couple people in the first class actually knew that. Yeah. All right, so remember you're taking this in parts. So f of x plus h, I would take the x plus h and plug it in to that 3x squared minus 2x plus 4. And then from that, subtract your original f of x and change the signs on the 3x squared, the negative 2x, and the positive 4. Combine your like terms and then put it all over h. And then at the very end, simplify it, see if you can condense your fraction or reduce your fraction. Questions on that one? All right, in this section, 1.3 was domain of functions. So remember, domain is all real numbers except for 3 cases. What are those cases?
There's a variable in the denominator.
Good. Variable in the denominator. And to find that, we just say the denominator cannot equal 0. What's the second way? Christian. Under square root. So I would say whatever's under the square root has to be greater than or equal to 0. And the last case is the combination of the two, right? Square root in the denominator. And so I set whatever's under the square root greater than 0. It can no longer equal 0 because now it's in the denominator. And all of that should be in interval notation. So you want to make sure you give me that in interval notation. All right, then we get to 19, 20, 21, 22, and 23, which are all based off of a graph. So the first thing you're going to do is take that f of x. You're going to plug it into either your graphing calculator, your handheld one, or your iPad. You're going to take a picture of it. So whether you're using the screenshot from your graphing calculator on the iPad or you're taking a picture of the little picture on your screen on your handheld, you're going to pull that graph in here and then you're going to answer questions based on it. So the first thing is domain and range. So if I'm reading domain and range from a graph, if I'm reading domain, what am I looking for? The values from what to what? Left to right. How about range? Good. And again, interval notation there. Increasing, decreasing behavior. So I'm looking, is it rising as I move from left to right? Is it falling as I move from left to right? Or is it horizontal or constant as I move from left to right? And again, that would be an interval notation. So if it's increasing and the x value is -1 and the stops increasing at +1, then my increasing is -1 to +1 with a parentheses on each. Remember, the only time you're going to deal with brackets in here is if it starts the very first point to the left or it stops the very first point to the left, to the right, constant. Other than that, they will be all parentheses. How do I find the zeros from a graph? What's another word for zeros? X-intercept. So if I'm looking at the graph, I'm looking for where this crosses the x-axis, okay? If you can factor it and solve it, then you can find the zeros that way, okay? But you're looking for zeros, roots, x-intercepts, all the same thing. Relative max and min, now I'm looking for every peak and every fall. This should be in an xy coordinate point, so you should give me like an answer like 2, 3. Remember, we did this on the graphing calculator. We have to set the left bound, the right bound, and then guess to find that max or find that min. That's how you're going to find the exact. And then even, odd, or neither. So how do I know a graph is even?
Symmetric to the y.
Good. Symmetric to the y. How about odd?
Symmetric to the origin.
Good. And then obviously neither is neither of those. Questions on graphs of functions or identifying functions, Christian?
Symmetric to the y, you have to plug in -x, right?
Yeah, but you can do it from the graph. Just look and see if it would fold over. But yes, you can do it from the equation too. So the f of x is your y, and the x would get replaced. All right, 1.4, graphing functions using transformations. So these are your shifts. This is your reflecting. Remember, if it's positive or negative on the front of the function, if it's positive, points up. If it's negative, points down, or it's upside down. The number in between the negative and positive sign and the actual function itself would tell you if it's a vertical stretch or a vertical shrink. If it's bigger than 1, it's stretch. If it's smaller than 1, it's a shrink. Or wide and narrow, or tall and flat. Inside the parentheses does what? What happens inside the parentheses or inside the function? That's your horizontal shift, okay? How about outside, adding or subtracting something to the function? That's your vertical shift, okay? So you're going to graph those and then give me domain and range. And then 1.5 is where we started the day, okay? So that kind of takes us all the way back to the beginning. Any questions overall on any of the content that's on this review packet? Okay.